Hello guys, welcome to this new video. Today we're gonna continue with Linux Kernel Module Development, and now I'm gonna do a small review of what I already did in the last video. So let's go back to the folder I was using, and so let's see what we accomplished with the first example. We are importing this. Oh, by the way, I updated somewhat the color theme that I'm using in NeoVim, and it's a bit more beautiful and we can understand a bit better the syntax highlighting and other stuff. So yeah, yeah, these two libraries are this library in particular is fundamental to write a Linux kernel module, and this one instead it's for using this br info, which is like print, it's a login function basically. And we have these two functions, init module and cleanup module, and in some way inside this module.h these two functions are called. Now I'm curious, so I wanna go back and check what happens in module.k. If I'm not wrong, no, I don't remember anymore where are the functions. Maybe in bin, no, include, no, it's definitely not here. Where are Linux headers file located? usr include. Oh, but no, that's the source file. usr, okay, makes sense. Yeah, it makes definitely sense. usr and sources. Yeah, and we have Linux, and in here we should have include. Oh no, it's not here. What? Yeah, oh, maybe lib. No, where the fuck are they? Oh yeah, cd Linux, and they should be in here. So if I open module.h, yes, here we go. So in my, let me open another one. So in that file we were calling these init module and cleanup module functions. So somewhere in here, if we search for init module, yes, here they are. So let me close this. These are either module local or the kernel's dummy ones. Extern, I'm even not sure what does extern in C, but let me see for a second. Yes. Oh no. Okay. Init module. Okay, let me search for extern. Extern, no, but this is in C++. No, I don't care about this. Yes, here it is. Extern keyword applies to C variables and C functions. Basically, the extern keywords extends the visibility of C variables and C functions. That's probably the reason why it was named extern. So it extends the visibility. So most people probably understand the difference between declaration and definition of a variable or function. For the sake of completeness, let's clarify it. Yeah, I know, okay. Extern is a short name for external. It is used when a particular file needs to access a variable from another file. So, extern int a when you write extern some data type, some variable name, no memory is allocated. Only the property of the variable is announced. Multiple declaration of extern variable is allowed within the file. The extern variable says to the compiler, go outside my scope, and you will find the definition of the variable that I declared. The compiler believes that whatever that extern variable said is true and produces no error. Linker throws an error when it finds no such variable exists. When an extern variable is initialized, then memory for this is allocated and it will be considered defined. A variable or function can be declared any number of times, but it can be defined only once. When we write int foo, okay, the compiler treats it as extern int foo. Since the extern keyword extends the function's visibility to the whole program. Am I recording? Yeah, the intrusive thoughts, sorry. The functions can be used anywhere in any of the files of the whole program, provided those files contain the declaration of the function. Okay, let's ask ChatGPT. In C, the extern keyword is used to declare a variable or function that is defined in another file or a different part of the code. It essentially tells the compiler, this variable or function exists somewhere else, without allocating memory for it or defining it again. Here's a breakdown of how it works. When you use extern with a variable, you're saying that the variable is defined somewhere else, so the compiler doesn't create a new variable, but instead links to the original one. So here I define the variable extern int count, declare the same variable from file 1. In this example, count is defined in file1.c and file2.c can access it using extern. This way, file2.c doesn't allocate new space for count. Okay, what about functions? By default, functions have extern linkage, so you don't need to use extern explicitly with function declarations. However, you can still use it for clarity. So this function is somewhat declared somewhere else, I guess. Extern is often used in other files to declare global variables or functions that will be defined in a corresponding .c file. This way, other files, including the header, can access them. Okay. I did not completely understand everything, but let's say that for now I will accept this definition. So let's go on. If I search for this init module, module init. No, definitely this is too much for me. So let's continue with our project. So yeah, in hello one, where is it? Yeah, we just used these two functions, and we saw that when we were loading the somewhat these functions gets called by this module.h library by themselves, and that's fine, that's cool for us. So when we were loading the kernels with sudo module load module, something like that. Else int module, sorry, and with list modules we were listing all the kernel modules that are running right now, and with remove module we were removing the module. And yeah, so we could see that those PR info functions were getting called. So let's move on with the second example. No. So here, demonstrating the module init and module exit macros. This is preferred over using init module and cleanup module. I will write this because I think maybe this is preferred over using init module and cleanup module. Oh. Okay, so we also need another library, which is init.h. So let's just import it. Init.h. Need it for the macros apparently, and let me change this kind of comment. Let's stay consistent in the file. So I can delete all of this. No, sorry. So we are using the same function to log. hello var2 slash on. Okay, and I guess that what this underscore init does is telling the library or whatever that these hello2 init functions is our init, like our module init function. And the static here, I don't know what it does. And same for this hello, sorry, for this exit. Oh, sorry, I forgot to return. Oh, this is void. So exiting doesn't return anything apparently. Okay. I know, okay. So the library is not like able to get by itself that this is the entry point and exit point of the module, but we need to say it with this module init hello2, which is probably a macro, I guess, and module exit. And then the license. Oh, I love all of this. GPL. Nice. Okay, so let's save all of this, and we need to edit the makefile also. What? So now we have 2 kernel modules under our belt. Adding another module is as simple as this. But wait a second, because I don't have hello1 here. So let me just add hello2. No. This is basically the same apparently. Let's just do y. And we're gonna put clean in here. Okay. Okay, let's see this drivers char makefile. Some things got hardwired into the kernel. Obj y. o random o. What is, wait, let me see the makefile again. obj I don't know anything about make, and I think I can understand something more here. I should read this thoroughly, I don't know how to say it, okay. Should just read this carefully, and yeah, it's full of informations. Let me search obj what? It's not in here, so it's just what? Is this just the name? What is objm? objm defined as that the kbuild system in kernel will build modname.o from modname.c. After linking this file, we'll get kernel module and modname.ko. The above line can be put in either a kbuild file or a makefile. When the module is built from multiple sources, an additional line is needed listing the files. Module name y, source 1 o, source 2 o. Building external modules. What? kbuild is the build system used by the Linux kernel. Wait, is this also here? No. Where is this coming from? Okay. Let's save this. No, actually, let's put this in my here. Okay. Nice. So let's go on. How to build external modules. kbuild is the build system used by the Linux kernel. Modules must use kbuild to stay compatible with changes. The author of an external module should supply a makefile that hides most of the complexity, so one only has to type make to build the module. Okay. To build external modules, you must have a pre-built kernel available that contains the configuration and other files used in the build. Also, the kernel must have built with modules enabled. If you're using a distribution kernel, there will be a package for the kernel you're running provided by your distribution. Okay. Command syntax. The command to build an external module is make -c path to kernel sources m equals $pwd. The kbuild system knows that an external module is being built due to the m equals directory option given in the command. Okay. Path to kernel sources. So if we watch our make file, you can see that we are doing this -c lib modules shell uname r, which is, I don't know, let's see, uname -r. Okay, it's the architecture type apparently, and build. And what does make -c do? Let's just search -c. Make -c. Never mind, it does compile a Linux kernel module apparently. To build against the running kernel, use lib modules uname -r, which is this, build. Then to install the module, just build, add the target module install to the command. Okay, we are skipping this because, oh no wait, we are doing it, modules, just doing modules. kdir, directory where the kernel source is located. Make will actually change to the specified directory when executing and will change back when finished. M equals $pwd. Informs kbuild that an external module is being built. Okay. The value given to m is the absolute path of the directory where the external module kbuild file is located. Okay. Okay, now I understand. Targets. When building an external module, only a subset of the make targets are available. The default will build the modules located in the current directory. So a target does not need to be specified. All output files will also be generated in this directory. No attempts are made to update the kernel source, and it is a precondition that a successful make has been executed for the kernel. If we type module, the default target for external modules, it has the same functionality as if no target was specified. Okay. Module install the external modules. Yes, okay. So this is gonna, if we write module install, I guess we don't need to insert the module. Clean with clean, okay. Cool. It is possible to build single files that are part of a module. This works equally well for the kernel. A module and new for external modules. Creating a kbuild file for an external module. In the last section we saw the command to build a module for the running kernel. The module is not actually built, however, because of build file is required. Contained in this file will be the name of the modules being built, along with the list of requisite source files. The file may be as simple as a single line. The kbuild system will build module name.o from module name.c. and after linking, we result in the kernel module name.ko. The above line can be put either in a kbuild file or a make file. When the module is built from multiple sources, an additional line is needed listing the files. I'm confused about this. Command to build a module for the running kernel. The module is not actually built. What? However, because a build file is required. Okay, and apparently this build file is this .ho file. Okay, here let's actually define it as like this. The kbuild system will build module name.o from module name.c, and after linking, will result in the kernel module name.ko. The above line can be put in either a kbuild file or a make file, and the module is built from multiple sources. Wait, because here we have this object module, yes, this stuff. And I don't know. When the module is built from multiple sources, an additional line is needed, listing the files. Okay. Further documentation describing the syntax used by kbuild is located in documentation kbuild makefile.txt. Okay, let's see the examples. An external module always include a wrapper makefile that supports building the module using make with no arguments. This target is not used by kbuild. It is only for convenience. Additional functionalities such as test targets can be included but should be filtered out from kbuild. File name makefile, if not equal, kernel release, okay. kbuild parts of makefile. Object term is 8123.0. This 8123 depends on 8123if.o, 8123pcio. These are other dependencies apparently. Else normal makefile. The check for kernel release is used to separate the two parts of the makefile. In the example, kbuild will only see the two assignments, whereas make will see everything except the two assignments. This is due to the two passes made on the file. The first pass is by the make instance run on the command line. The second pass is by the kbuild system, which is initiated by the parameterized make in the default target. We'll see. Okay, let's move on. Have a look at drivers char makefile variable example. As you can see, some things got hardwired into the kernel, but where are all of these object gone? You're right. Those familiar with shell scripts will easily be able to spot them. For those who are not, the object $config foo entries you see everywhere expands to object y and or object m. depending on whether the config foo variable has been set to Y or M. While we added it, those were exactly the kind of variables that you have set in the .config file in the top level directory of Linux kernel source tree. The last time when you said make menu config or something like that. Okay. Well, let's try this make file then. So if I do make call, sorry. Okay. So now if I do sudo lsmod, we don't have anything interesting, I guess. If we do like grep hello, there's nothing there. But if I do sudo ints module hello2.ku, I guess, and now if I do the same command as before, it's there. And then now I remove it with module hello, and I list again, it's not there. Now if I do ctl just this, I can see that. Let me go full screen. No, wait. I need to just see the wait, the last data, like last 5 minutes of the journal, which I don't remember how to do it. What? I get here. Yes. What? Okay, no, that's definitely too much. Stop. Let's do like 5 minutes ago. Let's go full screen. We have list module, insert module, hello, and we have a hello word 2. Nice. And goodbye word. Nice. It works. Good job. So for today, it's for today or not. Maybe I will take a break now. I don't know if it's gonna be in the next video or not, but in any case, this was the second example, and in the next one I'm gonna go on with hello3. That's it. So bye.